All right, my name is Michael Pace. This is going to be a brief overview of the basic refrigeration cycle. Just to do a quick rundown of who I am and what I have become. I started as a service technician in 2001, doing refrigeration work. In 2008, I moved my way up to a supervisor position. And then in 2015, I started teaching this stuff, and then in 2017, I got into the ESCO group, which is a further evaluation of the refrigeration cycle in the HVAC industry. So, before I go any farther, I just want to have everybody introduce themselves. So, I'm going to toss this ball to you. I want you to just say your name and then toss it to somebody else around the room, and we'll keep on going. So, what's your name, sir?
I'm Ryan Miller.
Okay.
I'm James Jeans.
Hey, James.
Jeffrey Onward.
Hey, Jeffrey.
Randall Jackson.
Randall Jackson. Got it. Close enough. All right. Let's see here. So, introduction to refrigeration. What's the purpose of refrigeration? All of this that we're going to talk about today in a nutshell is just to remove heat from a space where it's not wanted. So we're going to pull heat from some space that's not wanted, and then we're going to move that or reject it to an area that where it makes little to no difference. So a quick little example is what we have right here. Refrigerant can act like a sponge. When it goes into the evaporator coil, it can act like a sponge and then absorb all of the heat, or as much heat as it possibly can. And then we're going to take that and send it outside. And out there you can kind of squeeze that sponge and it'll reject all that heat or expel all of that heat. So that's a nice little example of it right there. We'll dig into that a little deeper. Just a couple questions first. In the summertime, does everybody sleep fairly comfortable at night in the house?
Yep.
You do?
I do.
You got a little climate control in there?
Mm-hmm.
What about in your vehicle in the summertime? When you hop in, you get going down the road, are you still sweating in there? It's Texas, so.
Yes.
Are you still sweating?
I'm not working in the truck.
If your air conditioner worked in your vehicle, you might be a little more comfortable in there. What else in your daily life uses refrigeration?
Your refrigerator.
There we go. So when you're hungry or thirsty, you run to the fridge and grab something. Everybody's got a fridge. Everybody's using one. It makes life a lot easier, right? We can have frozen meat. So if you want to go to the store once a week and get everything you need, milk's going to last a lot longer. Frozen food's going to stay longer. Fruit and veggies, whatever you put in there is going to stay longer. So it does make life a lot easier, right? So what about if that refrigerator stopped working? It would make a difference on our lives, right? It would make it to where you'd have to vegetables. You know, you'd have to grow them yourself. They're not going to last. A lot of our vegetables come from other areas, and so they arrive here on refrigerated trucks. If your AC in your car stopped working, for the most part of the year, it might not be as bad, but in the summertime here in Texas, it's going to get hot, and it's going to be very uncomfortable. So unless you can roll your windows down or something, it's on a rainy, hot day, it's going to be uncomfortable. So, yeah, I've been there too. So we do benefit from refrigeration cycle every day. Also, the medical industry relies heavily on the refrigeration cycle. Cryogenic freezers, which basically means a freezer that gets very, very cold, a few hundred degrees below zero, not just at zero. They rely heavily on the refrigeration cycle. Our vaccinations that we have today are produced and then refrigerated for transport. So we use it a lot, but how does it really work? So we're just going to do a quick little rundown of how the refrigeration cycle works. And it's going to be 4 main components today. So in the compression refrigeration cycle, as we talked about before, refrigerants, they're going to absorb heat inside the refrigerated space, and they're going to release heat outside, and the refrigerants will phase change. So when a refrigerant changes phases, is when we're going to get our refrigeration process to actually work for us. So when it goes from a liquid to a vapor, whenever it's boiling, it's going to absorb heat. And then when we saturate it back down from a vapor to it saturates back down to a liquid, it's going to expel the heat. And so that's the process that we use over and over and over to make this happen. Let's talk about a few parts and pieces, right? So the compressor, I'm going to draw that up here in a very crude example of a box. And following the box of a compressor, let's do a condenser coil or a condenser. We've got a line that's going to connect that. Let's go down here a little farther down. We're going to put in our metering device. And then the last component we'll bring up to another box. We'll label this an evaporator. And then we'll connect this back to the compressor. Just 4 components. It's the same 4 components that the refrigeration cycle is going to have, no matter what it's in. This is the crudest form of it. It can expand greatly from there. But I drew it like this for a reason. As you can see, the compressor, what it does is draws in a low pressure, and the compression results in a high pressure vapor. So right here down the middle, we can divide this into a high pressure and a low pressure. So on this side, we call it low. On this side, we can call it high. The compressor is going to draw in a low pressure vapor, and it's going to expel a very high pressure, high temperature, a superheated vapor in that process. That's the only job of the compressor, is to draw in just to create a pressure difference. So it's going to draw in a low side, a low pressure, and produce a high pressure from it. Likewise, down here at the metering device, it's going to do just the exact opposite to maintain that we have a high pressure on one side and a low pressure on another. All right, the condenser. Next in line right here, the condenser, you can see what it's going to do. We're going to try to condense down that vapor down to a liquid. So in a sense, you could say that this condenser is just going to have just a small amount of liquid in the bottom of it. Up here in the top, it's going to be condensing down. You can kind of try to draw a few little droplets there as it's condensing down into a liquid form in the bottom. I guess I could, let's label a few of these lines right here. So from the compressor to the condenser, we're going to have a line that we're just going to call it the liquid line. I'm sorry, the hot gas line. We're going to go into the condenser. Once it condenses down into a liquid, we're going to call this one the liquid line.
Is it also still hot?
This one is not going to be as hot as it was before, because the condenser is going to have a fan blowing on it, and I'll draw that in a minute too. The condenser is going to have a little fan blowing on it, so it's going to cool it down. And part of the process of it condensing is cooling off. So it's going to be closer to this system here sits outside. It's going to be closer to the temperature outside than it would be much hotter than that. Moving into the metering device, once it goes through the metering device, we're going to have a very short line right here. It's going to be called the distributor. And that distributor line is going to carry all of the refrigerant into the evaporator. Once it goes through the evaporator, it's going to go into the suction line to get back to the compressor. Also, this line from the evaporator to the compressor is kind of big, so I just kind of draw it like that. All right. Temperature difference causes a release of heat. We're going to take this hot, superheated vapor and go it into the condensers. Now, the condenser is going to have three things it needs to do. It's going to try to de-superheat, so let's see if I can write it over here. De-superheat. It's going to try to saturate, and it's going to try to subcool. It's going to try to do three things there. The term superheat, subcool, what we're talking about right there is whether or not the refrigerant is above or below its boiling point. So say water. All right, so water boils at 212 degrees. If I had water at 213 degrees, it's going to be in a vapor state. If it's going to be at 211 degrees, it's going to be in a liquid state, right? So at 211, that water would be 1 degree subcooled. At 213 degrees, it would be 1 degree superheated. So it's not necessarily a term of hot or cold. It's just relative to above the boiling point or below the boiling point. I could take a cup of water and say, here, this is some subcooled water, and toss it on you. It could be 211 degrees, so it's not necessarily cool. It's just a relative term to the saturation point of water in that situation. So, all right, so we've got three things condenser's going to do. Once it's de-superheated, it's cooled it off, it's saturated this temperature. To get this done, I guess I could draw us a little bitty fan motor right here. It's going to be blowing air across this coil. It's going to blow air across it. It's going to cool it off. It's below the saturation point. It's going to subcool the liquid a little bit. And we're going to have a solid line full of liquid. That's why we call it the liquid line, moving over to the metering device. Meter device, quick little pic of that right there. It's going to control the refrigerant flow into the evaporator. In other words, it's going to meter the flow. That's why we use simple terms as meter device. It's going to send this high pressure liquid. We're still in a high side right here. This has got high pressure liquid. And all of that liquid is going to have to go through a very tiny hole. And that's going to create a pressure difference as it moves across it. So if we've got a small little port right here, what typically happens as that moves through, about 25% of that gas turns into a flash gas. And as that 25%, it just poof, there's a huge pressure difference. It just automatically goes from a liquid to a gas. We call that the flash gas. And that also aids in that rest of that liquid as it's being filled up through the distributor line into the evaporator to start boiling off. So the evaporator, we should have majority of that evaporator full of liquid that is boiling off. So I put little boiling bubbles here. So the evaporator is full of liquid. We're boiling off. Remember from earlier, if a refrigerant is going from a liquid to a gas, is expanding out, it's going to be absorbing heat as it's expanding out. And so that's the main job. This is the evaporator coil. This is the coil that's inside our homes, and that's where we get our cooling from. Some people call it the cooling coil, but this is where that's going to happen at. So the evaporator, let's move on to that. There's a quick little picture of one. That's that's more for an industrial refrigeration setting, but it can be used for comfort cooling as well. What happens in there? The low pressure liquid refrigerant soaks up the heat, and the liquid becomes a low pressure vapor. So right here we've got this thing almost full, but then we're going to have the vapors kind of coming off and coming up the pipe and getting pulled back into the compressor right there, right? So we can't fill this thing up. We can't overcharge one, because if we have that liquid going back in the compressor, bad things are going to happen. The compressor is only a vapor pump. It cannot compress a liquid. It can only compress a vapor, and so we need to adjust our refrigerant charges so it stays right there where it needs to be. Process of evaporation once more. Warm air passes between the evaporator fins, and so we've got the evaporator over here. We would have an additional fan. Let's see if I can blow a residential fan right here, and that's going to be blowing air across this coil. It's going to be blowing across. And under design conditions, this may be pulling out, we may be putting in probably 80-degree air blowing across this evaporator. Now this evaporator is probably going to be operating somewhere around 40 degrees. And so we've got 40 degrees right there. And end result, as we blow this 80-degree air across this 40-degree coil, we're hoping to get somewhere around a 20% pressure drop, or difference in temperature. And we should have an end result of 60 degrees Fahrenheit right there. So this, under perfect design conditions, we would have a delta T of 20 degrees. Heat absorbed by liquid refrigerant as it boils into or expands, and the temperature of the airflow node of the evaporator becomes increasingly colder. So as it blows further through there, it's going to pick up more heat. It's going to absorb more of the heat from the building and send it out through this suction line to the compressor. All right, so the last set right there says air cools the conditioned area. That's great. The suction line, we've got all this heat in a vapor form, so the cycle repeats. Now this cycle is going to go in this direction right here. And it's just, the cycle is going to continue to repeat and repeat. So as the suction line pulls in that low pressure charge, we've got the heat right here. Now the air does not change hands. The outside air stays outside, the inside air stays inside, but we pull the heat through the refrigerant. As it goes back through that compressor and exits out that as a very hot gas, when it gets to the condenser, we're going to run this thing at a higher temperature, also at a higher pressure. So if you increase the pressure of a liquid, the boiling point is going to increase. Likewise, if you decrease the pressure, the boiling point will decrease. We've got a lower pressure here, we've got a lower boiling point. We've got a higher pressure here, we've got a higher boiling point. So this condenser may run somewhere around, I'd say, 100 degrees. Let's say on a good fall day or something like that, we may have 85-degree air going in. It's going to go across that 100-degree coil, and the air leaving out of that's probably going to be somewhere around, I'd say, probably 110 in this setup. If you ever going outside to your air conditioner at your house and you've kind of felt your arm above it, and if you feel that heat coming off the air conditioner coil, that's going to be the air the heat that's been rejected from the house. All right, so what did we talk about today? What did we learn? What the four components do: the compressor draws in low pressure vapor and changes it to a high pressure vapor. Condenser, it's going to condense down the vapor into a high pressure liquid. We're going to go into the meter device, and that's going to separate our high side and low side, but also where the high pressure becomes a low pressure. And then the evaporator, the low pressure refrigerant, soaks up the heat while the boiling point, or while it boils into the low pressure vapor. So that's about it in a nutshell, guys. Little thank you out there to HVAC Excellence in Modern Refrigeration and Air Conditioning and Goodhart Wilcox for those images I had put up there. And unless we've got any questions, that's all I've got.